Welcome back. I believe this is the last one of the laws. There's one more, but I guess this will be the penultimate one before the last one. So here's Dalton's law of partial pressure. Okay. What is partial pressure? We must ask, right? So the pressure due to any individual component in a gas mixture is its partial pressure. That is, say you have 10 different gases making up a mixture. The pressure that's due to each of those gas in that mixture is called a partial pressure, right? So it's individual component. Because of the identity of the gases themselves and how much of each of those gases present, they affect the partial pressure of that gas. Okay, when you add up all of those partial pressure of all of those 10 different gases, it gives you a total pressure. And that's called Dalton's law of partial pressure, which is sum of partial pressure of all gases in a mixture adding up to a total pressure. Okay, and the pressure of an individual gas itself is called a partial pressure. So in a nutshell, say I have represented 3, but I put a bunch of dots because you can have as many gases as you want. So the total pressure is equal to the partial pressure of gas 1 plus partial pressure of gas 2, partial pressure of gas 3, etc., etc. The first problem we're going to do is just a mere application of this formulae. But the partial pressure of an individual gas also is dependent on how much of it is present, and we will explore that component in a separate video or in a separate problem. Okay, so a container contains 3 gases, N2, O2, and AR, with partial pressures of the partial pressures is already provided for each of those gases, and it's asking for the total pressure. So P total equals partial pressure of N2 plus partial pressure of O2 plus partial pressure of AR. You do not have to convert anything because it's pressure. All you do is 23.38 kilopascals plus 40.9 kilopascals plus 13.7 kilopascals. Add them all up, and that's your Dalton's law of total pressure of the sum of partial pressure. So 23.3 plus 40.9 plus 13.7 is 77.9 kilopascals. Now, I could purposefully make this problem into a twofold process by asking the final answer in ATM. Okay, that's optional. Or in that case, I would give you the conversion factor for kilopascals to ATM. Once you get to this answer, you can go on to get the answer in ATM. So this is the easier version. The second is not necessarily difficult, but requires a little more work. Okay. Now, we said the total pressure is sum of all the partial pressures, right? But in the previous problem, the partial pressure was already given to you, so it made the problem easier. But what if you don't know, but you have to calculate it? Then partial pressure of one component, the one component is equal to mole fraction of that component. So X1 is the mole fraction. If you remember, we will work it out a problem so it makes sense. Mole fraction of component 1, okay? X2 would be mole fraction of component 2, and so on, okay? Times the total pressure, okay? So a mixture of 2 moles of hydrogen, 3 moles of NH3, 4 moles of CO2, and 5 moles of N2 exert a total pressure of 800. What is the pressure, partial pressure of each of the gas? Well, we know the total pressure, so we already know P total. P total is 800 torr. So we just have to find pH2, pNH3, pCO2, and pN2. All right? So how do we find mole fraction? Well, you have to first find the total moles, which is 2 plus 3 plus 4 plus 5. That's 9 plus 3, 12, 14 moles, right? To find the mole fraction of H2, you take 2 moles divided by 14 moles. To find mole fraction of NH3, it's 3 moles. Remember that, right? From your 3 moles over 14. That's the mole fraction. And mole fraction of CO2 would be 4 moles over 14 moles. And mole fraction of N2 is 5 moles over 14 moles. So if you do that, you'll get 2 over 14. You do not have to convert it to percent. So it's 0.142. That's the mole fraction. 3 over 14 is 0.214. Again, we're just using the knowledge from previous class. 0.285. And 5 over 14 is 0.357. Now we can go get the partial pressure of hydrogen is its mole fraction versus the total pressure, which is 800. Similarly, mole NH3 would be 0.214 times 800. I know it's a lengthy problem, but I would only ask you to do for one of them on the test. I wouldn't ask you to do it for all of them because it has no purpose to just do it all. Here we're learning the concept. So 0.357 times 800. So it'll be 0.142 times 800 is 113.6. Let's just do 114 torr. 0.214 times 800 is 171 torr. 0.285 times 0.285 times 800 is 228 torr. And then 0.357 times 800 is 286 torr. And that's it. So there's 2 versions of Dalton's law of partial pressure. Both are very easy, nothing difficult. So I have one more law to work out, and that's very, very easy of all of them. So stay tuned for that one.